In this lesson, we will learn how to use the OR operator to evaluate a logical statement or a logical expression within an if statement to allow us to redirect the flow of our program according to the result. We will still use an if statement without an else for this example. Okay, so let's go ahead and come up with an example that will lead to the use of an OR operator. So here's the scenario. Let's suppose you're doing an experiment and you will only accept temperatures that are below 40 Celsius or temperatures that are above 90 Celsius, which means anything between 40 and 90 will not, in that range, will not be accepted. Anything below 40 inclusive and above 90 inclusive, any of these will be accepted. Anything in between will be rejected. All right? So I need lower and upper limits to state what is, what temperature, or basically, what are they? Again, 40 degrees and 90. Anything below 40 is acceptable. Anything above 90 and equal to 90 will be acceptable. Okay, so we need to collect some sort of a temperature from a user, right? Sure. So we could have something like this. Double. So why did I pick double? Because temperatures could have a decimal point, right? So 33.4 is a valid temperature. Okay, let's call it temp or temperature. Okay, and we're going to ask the user to enter a temperature. Okay, so cout, enter a temperature. cin, into the variable temperature. Now the evaluation. If. Okay, so I know I need a couple expressions. I'm going to just put a curly brace here and another curly brace here. This will be my first expression, and it will be evaluated. And notice what I'm going to do here. This is called the OR operator. So these are the two vertical lines above your return key. Okay, and then here's my second expression, and then your if statement will close in this manner for the whole total evaluation. So my first expression is to make sure that is the temperature less than, 40, right? So is temperature less or equal to 40 degrees? Or, so they can't be at the same time less than 40 degrees and greater than 90. It's either or, right? Temperature greater or equal to 90. And put a 0.0 there if you're comparing float values against each other. It's really a good habit. Then we could say something like this. Acceptable reading. Right? So it follows the rules in which we wanted this to work. Let's see if it actually works. So let's compile and run. Let's make this a little bigger. Okay, let's enter 45 degrees. Now we know 45 is greater than 40 and less than 90. Let's see what happens. Nothing, exactly. Right? It's not within the acceptable range, which is in the lower band of 40 and the upper band of 90. Let's do it again. Let's run this. Now let's give it 33.5, right? So we know 33.5 is fine. 33.5, let's see if it picks it up. Acceptable reading. Let's pick something greater than 90, or exactly 90. Let's see if it will accept 90. Okay, So we're going to put 90, and it's an acceptable reading, right? So I hope you're getting this OR function, how it's working. So let's run it again. And let's put something a little below 90, like 89.999. Let's see what happens. Not acceptable. It's not 90. Okay? All right? Now you're going to say, wait a minute. In real physics, that is typically 90. I mean, how precise can you get to, how close can you get to 90? In that case, your algorithm needs to be slightly different. You are going to be looking for the difference between two values to compare. So we'll do another example where we can allow for a certain margin of error. So 89.999 could technically be 90. So you will have to decide on what will be an appropriate difference between 8999 and 90. Maybe 0.1 is fine. Maybe 0.01 is fine. Okay? So you could do something like that. We'll do that as another example. But for now, let's see what just happened here. Let's try to understand what just happened here. As long as the temperature is equal to or less than 40, that will be an acceptable reading. Notice we don't even bother over here if you've entered any temperature below or equal to 40. It does not matter what the other term does or what is its value, because you can only have one value. It's this temperature. Whatever you entered here, okay, you know this will be false for this scenario. Okay? So only this one can be true if you enter 33.3, for example. But that's good enough for the whole expression to be true because you are using an OR operator. Okay? So I hope I dissected it enough for you to understand this concept. Great. Now, do we have an equivalent way of handling an OR with simply if statements and no OR operator, just like we did with the AND? With the AND, we had nested if statements. For OR, you're going to have what we call serial if statements. So let me show you how to do this. So let me just copy all of this. It's going to be a very similar problem. And let's create a new file and see how this behaves without using an OR operator. So I'm going to remove the use of OR operator. Okay? But we're going to get the same, effect. Now watch how you work this. You take this out. You take this parentheses out. So you're evaluating against this range. Next, let me just copy all of this. Don't make it nested, so no curly braces here or anything, or, so this is another if statement, except here you're going to change this to greater or equal to 90. So now, if temperature was less than 40 or equal, then this will execute, this will never execute. It will have the same exact effect of having what we call an OR operator, just like we did here. So this here allows you to combine all of it in one line. This here, you could do it with two if statements, two separate if statements, and get the same effect. Let's save this. Let me just compile and run. It will save it for me. And this will be example 22. And we'll see that the effect is the same. Just make this a little bigger. And let's enter 34.5, acceptable reading. Notice the second if statement just ignores it because it will be a false. It doesn't really ignore it. It will evaluate and finds out that it's false, so it will skip the acceptable reading, the second acceptable reading line. Let's go ahead and put a higher temperature. Let's put 101.2, right? So the first if statement will be false. The second if statement is true. Not a problem. Let's put something in between now. And let's see if it actually filters out the temperatures in between. And let's put a 50.6, right? And sure enough, it filters it out. And that's where an OR statement comes in really handy. Or if you do not want to use an OR statement, you could use two serial if statements written up in this manner. So I hope this was informative. So the next time what I will do is when we compare float numbers like these, can we set a certain level of precision where some values are acceptable? Okay? And that would be a really, really, really good way to get close, but, like let's say you can decide that 0.01 is an acceptable value. So it doesn't have to be exactly, say, 90. 90.1 is acceptable. 89.9 will be acceptable, okay? Below that or above that may not. Depends on what your scenario is. So, and that is where I will introduce you to reusing another math function called ABS, or absolute value. So we're going to look at the absolute value of the difference, and we want to make sure that that tolerance is within a certain range, and then we can take it. So that's our next video, is where we're going to use tolerances to accept a value that's close enough. Okay? And that's very useful if you're doing measurements in physics or things of that nature. Excellent. So I'll see you again for the next video.